the speed of light. 299,792,458 meters per second, the fastest thing in the known universe. You learned that in school, you accepted it, and you moved on. But here's what nobody ever asked you. Why? What stops anything from going faster? You have a number. You don't have an answer. And the real answer, the one Feynman spent decades chasing, is so much stranger than a speed limit that it will fundamentally change how you understand reality, time, and your own existence. Let's start with something simple, something you did today without thinking about it. You flipped a light switch, the room went dark, you hit the switch and the light appeared instantly. No delay, no hesitation. You've done this 10,000 times in your life, and every single time your brain told you the same thing. That light fills a room at the exact moment you flip the switch, that it travels from the bulb to your eyes in 0 time. And every single time your brain was wrong. There was a delay, a tiny, imperceptible, laughably small delay, but it was there. And the fact that it's there, that light takes time to travel at all, is the thread that unravels everything you think you know about the universe. For most of human history, the greatest minds that ever lived believed light traveled at infinite speed. Aristotle believed it. Kepler believed it. Descartes argued for it passionately. The idea that light could have a measurable speed seemed absurd. When you open your eyes in the morning, you see the entire room at once, not piece by piece, not wall by wall, all of it, instantly. So how could light be anything other than instantaneous? It took a stubborn Danish astronomer staring at Jupiter to prove them all wrong. In 1676, Ole Romer was working at the Royal Observatory in Paris. His task was almost boring in its simplicity. Track the orbit of Io, one of Jupiter's moons. Predict when Io would slip behind Jupiter's massive shadow and when it would pop back out on the other side. It should have been clockwork. Io's orbit was stable, predictable, a cosmic metronome. Every 42.5 hours, like a train pulling into a station. And for a while, Romer's predictions were perfect. But then, month after month, the numbers started drifting. Sometimes Io appeared right on schedule. Other times it was late. And then later in the year, it would start arriving early, not by random amounts, by a pattern that grew and shrank over the course of a year, a pattern nobody could explain. Romer stared at this for months, and then he made a connection so brilliant that it would have been laughed out of the room if he hadn't been able to back it up. Io wasn't late. The light carrying the image of Io was late. When Earth was on the far side of its orbit, farther from Jupiter, the light had to cross a greater distance to reach his telescope. 6 months later, when Earth swung to the near side, that same light arrived sooner. The moon was always on time. It was the messenger that was slow. Romer calculated that light took about 22 minutes to cross the diameter of Earth's orbit. He was off. The actual number is closer to 16 minutes, but the magnitude of his insight was staggering. He proved that light was fast, impossibly fast, but it was not infinite. It had a speed. It could be measured, and anything that can be measured has a limit. But here's where it gets strange. Knowing the speed of light didn't answer the question. It deepened it, because now physicists had a new problem. Why that speed? Why 299,792,458 meters per second and not something else? Not faster, not slower, not infinite. What force, what law, what rule of the universe locks that number in place? This question haunted physics for over 200 years, and the person who finally cracked it wasn't looking at light at all. He was looking at a clock and a train. In 1905, a 26-year-old patent clerk in Bern, Switzerland, published a paper that would dismantle the entire Newtonian framework of reality. His name was Albert Einstein, and he wasn't working at a university. He didn't have a lab, he didn't have funding. He had a desk, a pile of patent applications, and an idea that wouldn't leave him alone. An idea he later said came to him while riding a streetcar, looking back at the clock tower in the Bern train station and imagining what would happen if his streetcar pulled away at the speed of light. Would the clock freeze? Would time stop? That thought experiment, a young man on a streetcar staring at a clock, produced the most consequential paper in the history of physics. Einstein didn't discover the speed of light. What he discovered was what that speed meant, and what it meant was terrifying. Einstein realized something that sounds simple but breaks your intuition completely. The speed of light is the same for everyone, always, no matter how fast you're moving, no matter what direction, no matter what. If you're standing still and I'm flying past you at 90% the speed of light, and we both measure a beam of light, we get the exact same number. 299,792,458 meters per second, not adjusted, not relative to our motion, identical. That shouldn't be possible. In everyday life, speed is always relative. If you're on a train moving at 100 kilometers per hour and you throw a ball forward at 50 kilometers per hour, someone outside sees that ball moving at 150. Speeds add up. But light doesn't play by those rules. Light always moves at sea for everyone, in every direction, under every circumstance. And Einstein asked the most dangerous question in the history of physics. If the speed of light never changes, what does? The answer shattered the world. Time changes, space changes. If the speed of light is fixed, if nothing in the laws of physics can change that number, then time itself has to bend. Space itself has to warp. The faster you move through space, the slower your clock ticks. Not metaphorically, not as a thought experiment, not as an optical illusion. Your atoms vibrate slower. Your biological processes decelerate. Your heartbeat, your thoughts, your neural firings, your aging, all of it genuinely, physically, measurably slows down. And here's the part that makes people uncomfortable. From your perspective, you feel nothing. Everything feels perfectly normal. It's everyone else who has sped up. This is time dilation. And it has been measured so many times with so many instruments that questioning it would be like questioning whether gravity pulls things down. But wait, that's not even the most disturbing part. That's just the setup. I'm about to show you where this really leads, and I promise you it goes somewhere you're not expecting. In 1971, two physicists named Joseph Haffel and Richard Keating did something beautifully, almost comically simple. They packed cesium atomic clocks into luggage. They bought commercial airline tickets, regular seats on regular passenger flights. They flew eastward around the world on one trip, westward on another, and then brought those clocks back and compared them with identical clocks that had stayed on the ground at the United States Naval Observatory. The clocks disagreed, not by much, by billionths of a second. But the disagreement matched Einstein's equations with extraordinary precision. The eastward clocks, which were moving faster relative to the ground due to Earth's rotation, lost time. The westward clocks gained time, exactly as predicted 66 years earlier by a patent clerk imagining a streetcar pulling away from a clock tower. Let that sink in. The next time you're on a flight anywhere in the world, time is literally passing at a different rate for you than for the people on the ground below. You are aging at a slightly different speed than your family, your friends, everyone who stayed behind. The difference is tiny, nanoseconds over hours of flight, but it is physically real, mathematically precise, and has been replicated so many times that it's considered one of the most robust experimental confirmations in the history of physics. And every single day, without knowing it, you rely on this being true. The GPS satellite orbiting above your head right now moves at about 14,000 kilometers per hour and sits 20,200 kilometers above the surface. At that speed and altitude, time dilation and gravitational effects cause its clock to drift from ground clocks by 38 microseconds per day. That sounds like nothing, but if GPS engineers didn't correct for relativistic effects, your position on Google Maps would drift by roughly 10 kilometers per day. Your Uber wouldn't find you. Your plane couldn't land. The entire navigation infrastructure of modern civilization runs on the fact that time bends when you move fast. Every time you open maps on your phone, you are using the consequences of Einstein's revelation. That is not abstract physics. That is your Tuesday afternoon. If this is already reshaping how you think about speed and time, think about what comes next. If this channel makes you see things the way no other channel does, hit subscribe, because what I'm about to tell you is the part that Feynman considered the most profound insight in all of physics. Here is the question Feynman kept circling back to. Why can't you reach the speed of light? Not as a practical problem, not because rockets aren't powerful enough, as a fundamental impossibility. What happens when you try? The answer is that the universe itself resists you. As any object with mass accelerates toward the speed of light, its relativistic mass increases, not by a little, toward infinity. At 99% the speed of light, your effective mass has already multiplied by a factor of 7. At 99.99%, it's over 70 times your rest mass. To reach 100%, you would need infinite energy to push infinite mass. The universe doesn't have a sign that says speed limit. It has a wall, a mathematical wall woven into the geometry of space-time that makes reaching C as impossible as dividing by 0. You can get closer and closer asymptotically forever, but you can never arrive. But Feynman saw deeper than the wall. He saw what the wall was protecting, and this is the part that collapses everything you thought you understood. The speed of light is not a speed. Let me say that again, because your brain is going to resist this. The speed of light is not a speed. It is the maximum rate at which anything in the universe can change. It is the speed of causality, the speed at which one event can influence another event, the speed at which information, any information of any kind, can propagate through the fabric of space-time. Think about what that means. If you punch a wall, the pain signal travels to your brain at some fraction of this speed. If a star explodes, the news of that explosion cannot reach the nearest planet faster than this speed. If you flip a switch, the circuit cannot complete faster than this speed. Nothing. No signal, no force, no information. Nothing can outrun this number, not because of engineering limitations, because of the geometry of reality itself. Light doesn't travel at this speed because it's special. Light travels at this speed because it has no mass, and therefore nothing slows it down. It simply moves at the maximum the universe allows. If light didn't exist, if every photon in the cosmos vanished right now, 299,792,458 meters per second would still be the universal speed limit, because it was never about light. It was about the deeper structure of space-time. Let me put this another way, because this is the part Feynman called the most beautiful idea in physics. You are always moving through space-time at the speed of light. Always. Right now. Sitting still. Reading this. This is not a metaphor. This is not poetic language. This is the mathematics of special relativity, and it is exact. Everything in the universe, every atom, every person, every planet, every grain of sand moves through the four-dimensional fabric of space-time at exactly c. The question is not whether you're moving at the speed of light. You are. The question is what direction. When you are sitting perfectly still in space, all of your motion goes into the time dimension. You are hurtling through time at 299,792,458 meters per second. When you start walking, you redirect a tiny fraction of that motion from the time dimension into the space dimension. When you drive, a little more. When you fly, a little more still. Your speed through space goes up, and your speed through time goes down. They trade. They always trade. And they always add up to exactly c. Think of it like this. Imagine you're walking north at 5 kilometers per hour. If you turn slightly northeast, some of your northward speed is now going east. You're still moving at 5 kilometers per hour total, but less of it is going north. That is exactly what happens with space and time. Your total speed through space-time is fixed at the speed of light. When you move through space, you steal from your movement through time. That is time dilation. Not a side effect, not a consequence. The actual, literal mechanism. Space and time are two directions in the same fabric, and you cannot increase your speed in one without decreasing it in the other. And light? A photon redirects all of its motion into space, 100%, zero into time. Think about what that means. From a photon's perspective, it does not experience duration. It does not experience a journey. A photon emitted from a star 13 billion years ago that hits your retina tonight crossed 13 billion light years of space in what was, from its own frame of reference, zero time. For the photon, there was no journey. It was emitted and absorbed in the same instant. The entire history of the universe, every galaxy forming, every star igniting, every civilization rising and falling, 13.8 billion years of cosmic evolution. From light's perspective, all of it happened simultaneously. Light doesn't experience time. For a photon, the universe has no duration. That is not philosophy, that is physics. And if your brain is fighting this good, that means you're paying attention, because this is not speculation. CERN demonstrates this every single day. And that is not speculation. CERN has demonstrated this with muons, subatomic particles created in their accelerators. A muon at rest decays in about 2.2 microseconds. But when accelerated to 99.94% of the speed of light, muons survive over 12 times longer than they should. From our perspective, their clocks have slowed down so dramatically that 2.2 microseconds of muon time stretches across nearly 30 microseconds of our time. This is observed every single day, thousands of times. It is one of the most replicated results in all of experimental physics. This is just the beginning. There is something even deeper hiding beneath space-time itself, something about the relationship between energy and information that Einstein only glimpsed and that quantum physics is still wrestling with. That is a story for another day. And trust me, that story is even more unsettling than this one. If you want to go deeper, that video is right here. But before you leave, come back to where we started. That light switch, that dark room, that moment of flipping it, and the room appearing to light up instantly. It was never instant. That light left the bulb and traveled to your eyes at 299,792,458 meters per second. And in the time it took those photons to cross your room, they experienced nothing. No time, no duration, no journey. From their perspective, they were at the bulb and at your eyes simultaneously. And while they moved entirely through space, you sat there moving entirely through time at that very same speed. Two objects in the same room, both traveling at the speed of light in perpendicular directions through reality. The photon cutting through space, you cutting through time, both locked at the same velocity, both unable to stop. Everything you see, everything you touch, everything you have ever experienced is happening on the surface of a four-dimensional fabric that is carrying you forward at the one speed the universe will never let you exceed. You can redirect it. You can trade time for space and space for time. But you cannot slow down and you cannot speed up. You are pinned at sea. You always have been. You are not still. You have never been still. Right now, in this very second, you are falling through time at the speed of light, and you always will be.